The aim of this tutorial is to help you with synthetic division. In this question here, we're going to be using synthetic division to help us find out the values of P and Q in this function. Right, so I'll read the question out. It says, if x plus 1 and x minus 3 are factors of this function, find the values of P and Q. So to do this, we need to set up a synthetic division. The first value that's going to go in is x plus 1 is a factor, which means that minus 1 is going to be a root. So if we put minus 1 into this synthetic division, we should end up with a 0 at the end here. So the coefficients are 2, minus 5, P, and Q. Now just to remind you that if there was, let's say that x squared was missing there, did not exist, then you'd have to write a 0 in there. So you must sort of keep the place value there. It has to be an x cubed, that one has to be something x squared. Even if there's not one, you still must put something there. Then you've got your x, and then you've got your number that you add on at the end. So first of all, we bring the 2 down, and we start doing this synthetic. Now we do minus 1 times 2 is minus 2. We add these two together. Minus 1 times minus 7 is 7. And now we add 7 and P together, which gives us 7 plus P. Then we multiply this now, minus 1 times this, which will give us minus 7 minus P. And then we add these two together, which gives us minus 7 minus P plus Q. Now if x plus 1 is a factor, then as I said, this bit here must be 0. So our first equation we can write down is minus 7 minus P plus Q has got to equal 0. And if we just tidy that up a little bit, we can rewrite that as Q minus P has got to equal 7. Now we can't do anything with that just now. Missed all that. Let's just say that again. So this bit here has got to equal 0. So we write out an equation equal to 0. And the reason why this equals 0 is because x plus 1 is a factor. And I've rearranged it. I've put the 7 on minus 7 onto the other side, which makes it plus 7, and I've just swapped these two letters around. So that plus Q I've written here, and the minus P over there. This makes it look a little bit tidier. The next thing we're going to do is we're going to use the other factor, which is going to be x minus 3, and we're going to use that in the same type of synthetic division, and we should end up with a different expression at the end here. So this time, if x minus 3 is a factor, that means that 3 must be the root. So again, we're going to put the coefficients of all the x terms along the top. So it's 2 minus 5 P and then Q. First of all, when you start this off, you bring the 2 down. 2 times 3, or 3 times 2 is going to give you 6. You add these two together, and that gives you 1. 3 times 1 is 3. We add these two together, gives us 3 plus P. And then we multiply 3 times 3 plus P, and we get 9 plus 3P. And then lastly, we add the last two expressions together, 9 plus 3P plus Q. And again, if x minus 3 is a factor, that means this bit here must be equal to 0. So we can write down that 9 plus 3P plus Q has got to equal 0. And if we just tidy it up, we want, again, if you look over here, we want to make it look roughly the same as this. So we've got the Q first, then we've got the P. So I'm going to rewrite that as Q first plus the 3P, and that's going to equal minus 9. Now with these two equations, we can solve them synthetically to help us work out what the value of Q and P are going to be. So there's many different ways of doing this. You could, because they've got q here and q here, you could make them equal to each other by putting the 3p onto the other side and putting this p onto the other side, and that's probably the easiest way of doing it. You could also use the elimination method, but I'm going to choose to rewrite both these equations as q is equal to 7 plus p, so just pop that p on the other side, and then here q is going to equal minus 9, and put that on the other side, minus 3p. Just go on my page, minus 3p. So to solve them, we then can say if q can equal this and q can equal that, we can then write down 7 plus p has got to equal minus 9 minus 3p. And to solve that equation, I bring the 3p minus 3p onto the other side, becomes 4p, and I bring the 7 onto this side, and it's going to become minus 9, take away 7, it's going to be minus 16. Divide that by 4, and I end up getting p is equal to minus 4. And then if I know if p is minus 4, we can work out q by putting it into either this expression here, so this equation here, or this equation here. So if I put it into this one, I would get 7 plus a minus 4, so I get q is equal to 3. And if I put it into this one, I should get exactly the same. Let's just check that. So it's going to be minus 9 minus 3p. So minus 3 times 4. So minus 3 times a minus 4 is 12, or plus 12. So minus 9 plus 12 again is 3. So that works out fine. So the values for p and q are going to be minus 4 and 3. Which means if we put, go right back to the start here, if we replace this value here with a minus 4, and this value here with 3, you would have a function that has x plus 1 and x minus 3 as factors. Hope that helps you with your synthetic division.